to take you all on an exciting journey about one of the interesting topics and thrilling observations about our sun, which are sunspots. Today is the third and the last day of the Sunspots virtual bootcamp. In the previous sessions, we introduced you to sunspots and their relation to the solar magnetic activity, in addition to the way of calculating and predicting sunspots' position, so you can do it yourself. Today, we will be ending this virtual bootcamp by discussing very interesting topics, which are sunspots' relationship to Earth's magnetic field, radiation received by Earth, climate change, and the ozone layer. We hope you enjoy today's lesson.
Hello everyone. Today we will discuss about the effect of the solar activity on Earth and how Earth is protected. First, solar flares and geomagnetic storms are examples of extreme sun activity that can send bursts of energy toward Earth. So what type of energy it is? The energy can be one of three forms. First, the ionizing radiation. Second, the magnetic energy. Or third, the ultraviolet radiation. Sunspots are strong magnetic fields on the surface of the sun, which can become twisted and storing energy like a rubber band. The magnetic fields that create sunspots prevent some of the sun's heat from reaching the surface of the Earth. The second type of protection is the ozone layer. It acts as a filter for the shorter wavelength and highly hazardous ultraviolet radiation. When the sky is clear, there is an inverse relationship between the stratospheric ozone and solar ultraviolet radiation measured at Earth's surface. For consecutive clear sky days, large but natural change in ozone level in the stratosphere above cities can affect the solar ultraviolet radiation at the surface significantly. Ultraviolet index values increasing or decreasing inversely with large daily decrease or increase in ozone. So the greater the ozone, the less ultraviolet radiation that Earth will receive. The third type of protection is the magnetosphere. The Earth is plagued with a protective region of space called the magnetosphere. As you can see in the picture, in the blue area, is the magnetosphere. It is a magnetic field that surrounds and protects the Earth from the solar wind. However, some of the wind's particles pass through the magnetic field into the ionosphere. The ionosphere is one of the atmosphere's layers that is 90 kilometers above the Earth's surface. Trapped in the ionosphere, the particles head toward the pole, as you can see in the picture, toward the north and the south poles. The ionosphere is dominated by charged particles created by solar rays, stripping away some of the electrons from the atoms of oxygen and nitrogen. The ionosphere, in its normal state, reflects the longer length radio waves back on Earth. So we talked about the protection, but what can we see actually in Earth as an effect? The effect of solar wind on the Earth that are visible to human eye are the the solar wind on the Earth that are visible to human eye are the area borealis and the North Pole and the area australis in the South Pole. When they hit the atmosphere, they collide with atoms and molecules. As a result, colorful photons that light up the sky. This is due, of course, to the magnetic field lines curve around Earth.
Please close your mics.
The second effect is the climate change. The first most noticeable effect of sunspots in the climate were the northern and the southern lights. With sunspots come an increase in the ultraviolet rays that emit from the outer ring of the sunspot toward Earth. This increase in ultraviolet rays affect the chemistry of the outer atmosphere and the energy balance on Earth. Sunspots affect Earth's climate because sunspots on the surface of the sun can reduce the amount of energy and light distributed to Earth. This decrease in energy can result in colder weather and even many ice ages on parts of Earth that are farther from the equator. To these ends, I wanted to ask you, what is the most interesting thing you learned in this boot camp? If you can raise your hands and answer this question.
Please raise your hand and I'll pick one so you can speak. Yeah, Faisal?
Well, I think I learned a lot. I had no idea what sunspots were before the sessions that you gave us. But through these courses, I think I've learned a lot about them and about what they are. And I appreciate your time and I appreciate your effort into doing this, for doing this.
Oh, thank you very much. This is highly appreciated. We're glad to hear that. For others, what is the most interesting thing that you've learned in this boot camp? Please raise your hand. Amira?
It was interesting to learn about how many effects they have on Earth.
Yeah, it was actually also very, very interesting for me when I learned them by myself. So thank you for sharing that. Anyone else? So I guess we can go to the next slide.
Okay, so after we knew what's the most interesting things you learned in this boot camp, I want to sum up and recall everything we learned in this boot camp just quickly in some important points. The first point is that sunspots are temporary distributed areas in the solar photosphere that appear darker. The second point is that the sun's magnetic field goes through a cycle called the solar cycle every 11 years. The third point is that sunspots are darker because they are cooler than the area around them. The fourth point is that sunspots decrease the energy directed toward Earth. Fifth point, Earth's magnetic field protected from the solar wind. Last but not least, the sixth point is that solar activity can cause the northern and southern lights and affect the climate change. And now, feel free to ask any question about today's lesson or about the boot camp in general before playing Kahoot with Lana.
Do you have any questions? So I guess that there are no questions. We can start playing the Kahoot game.
Okay, so now prepare your devices and let's play with Lana.
So now we are having a Kahoot game. Please enter the game pin number shown in the screen. The game pin is 7800892. We will be waiting for more players to join. So I guess we'll be starting the game. So the first question is, what is not a form of the resulting energy from the sun's activity? Is it the ionizing radiation, sunspots, magnetic energy, or the ultraviolet radiation? Click on the right answer. So let's see the answer. So the correct answer is sunspots. Sunspots is not a form of the resulting energy from the sun's activity. So well done to you all. The next question, what can be twisted on the sun's surface due to the strong magnetic fields? Is it the sun's outer corona, radiation, sun's core, or sunspot? Please click on the right answer. So the right answer, or the correct answer, is sunspots. Well done to you all. The next question, the ozone layer acts as a filter for the shorter wavelength and highly dangerous UVR. Is that true or false? So the correct answer is true. Well done. Faisal is at the top right now. The next question, what are the visible effects of the solar wind on the Earth's poles? Is it the auroras, solar flares, eclipses, or the Earth's magnetic field? So the correct answer is auroras. Well done. Faisal is still at the top. The next question. Auroras that appear on the Earth's south pole are called aurora borealis, aurora antarctic, or northern lights, aurora australis. Please click on the right answer. So the correct answer is aurora australis. Well done. The next question. The coming questions are basically a recap of what has been presented throughout the whole Sunspots virtual bootcamp. So this question is, sunspots consist of gravity, asteroid swallowed by the sunspot, about by the sun, strong magnetic flux, or radiation. Please click on the right answer. So the correct answer is the strong magnetic flux. Excellent. Faisal is still at the top. The next question. Why do sunspots appear darker than the area around them? Is it because they have greater temperature, they are cooler, they are deeper, or they have the same temperature?
If you can remember this, we said that the difference between them and the area around them is around 2000 degrees Celsius. But is it cooler or higher temperature?
So the correct answer is because they are cooler. If you remember, we mentioned that they're about 2000 Celsius degrees lower than the rest of the surface, and they're about 4000 Celsius degrees compared to the sun surface, which is about 6000 Celsius degrees. Faisal is still at the top. So the next question, Edwin Hubble was the first to discover sunspots. Is that true or false? If you remember the first scientist, we even show some of the drawings that scientist made. Is it Edwin Hubble or someone else? So yeah, the correct answer is false. That scientist is basically Galileo Galilei. The solar cycle takes about 22 years, 15 years, 11 years, or about 30 years. Please click on the right answer. So the correct answer is about 11 years. So the next question is, the largest sunspot ever detected was at the size of planet Jupiter. Is that true or false? I guess that's an easy question. So the correct answer is true.
If you
Now
remember,
for the
we
last,
mentioned that.
yeah.
Sorry, Nana. But if you remember, we mentioned that the average size of the sunspot actually at the size of Earth, but the largest size observed is in the size of planet Jupiter.
For the last question, the competition is getting tighter now. For the last question, did you enjoy the Sunspots bootcamp? I hope you did. So these are the winners. Congratulations to Faisal, Hanan, and Siba. You all did very well.
Thank you.
So I guess our Sunspots virtual boot camp has came to an end. I hope you all enjoyed it and found it useful in getting you steps closer to your passion in space science. Thank you very much for attending and for your attention for the whole virtual boot camp. Elaf and I are very glad that we had the chance to present the boot camp for great attendance like you. And we can't wait to meeting you again in coming camps and programs with the Saudi Youth Space Association. Keep learning and have a good night.